Hi, and welcome to this Spark Publishing video course titled Learning PySpark. My name is Tom Drabas, and I will be delivering all the modules of this course. A little bit about me. I'm a seasoned data scientist with over 15 years of international experience. I currently reside in Seattle area, where I have been working for Microsoft for the past 2.5 years. In my day job as a data scientist, I use Spark pretty much all the time. Prior to joining Microsoft, I have worked for Vodafone Australia while pursuing my PhD degree in operations research. I have also worked in consulting, analytics, logistics and airline industries over the years. I'm an author of Practical Data Analysis Cookbook from Pact and a co-author of Learning PySpark and the PySpark Cookbooks, also from Pact. If you live in Seattle area, you can also find me speaking on meetups and conferences where I cover topics ranging from Spark to machine learning and deep learning. Follow me on Twitter, where I post from time to time about issues that I care about. These are by no means limited to data science only. If you have any comments or questions, you can ask them there. I can also be contacted via LinkedIn or at my email address tom@learningpyspark.com. So, this course is divided into 3 parts. This is the first of them. It is designed for data scientists and data engineers who work with problems that no longer can fit on their machines, and they are looking for a solution that is fast and scales without problems. The first part is titled Introduction to PySpark. This video is an introduction to the course, where we will give you a very brief overview of what PySpark is and what will you learn throughout the course. Spark is a powerful, distributed and easily scalable data processing engine. Matej Zakaria, whose idea was to write Spark, had grown increasingly disgruntled with Hadoop after his queries were running for hours and eventually failed. As part of his PhD, he developed Spark. Spark, just like Hadoop, runs on commodity machines like desktops, laptops and normally on normal data center servers. Its super-fast execution times are achieved thanks to storing the data in memory. In addition to that, Spark is following so-called lazy execution process and heavily optimized processing engine. As we will learn throughout the course, the transformations do not do anything until an action is called on an RDD or a data frame. Spark's API is available in multiple programming languages, even though the Spark's engine is written in Scala. In this course, we will be solely focusing on Python, but you can also use Java or R, in addition to, of course, Scala. Spark's environment is open source, so it's easily extendable. However, if you are not a computer scientist or a software engineer, you have nothing to worry, as the environment provides enough tool to achieve almost any task. This includes quite rich, distributed machine learning libraries that can do almost any task a data scientist can face. So, what will you learn in this course? First, we'll provide a very brief note on PySpark, or as we call it, the PySpark primer. In this section, we'll briefly introduce the most important terms and aspects of PySpark. In the section that follows, we'll describe one of the most fundamental data structures available in PySpark, the resilient distributed datasets. In section 2, we'll also cover a wide array of transformations available for RDDs, as well as how to read data into an RDD. In section 3, we will continue working with RDDs, but now we'll explore the available actions. In this section, we'll also cover how to save data from RDDs. Section 4 focuses on Spark data frames and their transformations. Spark data frames, starting from Spark 2.0, have become somewhat default data structure for Spark users, superseding RDDs. In this section, we'll explore how to use them. The last section, for this part, will explore the practical ways of processing data with data frames. We will be discussing how to select, filter, aggregate and transform the data, as well as how to store the data from data frames. The course is designed for both data scientists and data engineers that want to jump right into the Spark work. We will not be covering the basics of Python programming, so intermediate programming skills in Python are necessary. However, we do not require that you know anything about any distributed systems and how they work. Such knowledge is welcome but not really required. To follow this course, you will need either a laptop or a desktop. Spark doesn't install easily on Windows machines, so for this reason and for this course, we assume that you have an access to either a Linux or a Mac boxes. Virtual machines are also welcome, and for the Windows users, our preferred way of working with Spark on a PC. In terms of an environment requirements, you need to have either Python 2.7 or 3.5 installed on your machine. We prefer Python 3, and all the code available in this course reflects this. Also, you will of course need a Spark environment ready for you to use. We require the Spark 2.0 at a minimum. Optionally, you can also install Livy and Spark Magics, but these are not really necessary. We use them from time to time, but this is not truly required. Thank you for watching this video, and I hope to see you during the course. I also hope that you will enjoy it as much as I did designing and developing it. Thank you.